Everybody, thank you for joining us for our webinar today. So today we're talking about mixing a lot of different legacy paradigms with modern architectures, modern systems. So on our previous webinar, we had Robert Strandover, and in that webinar, we talked about all of the different aspects about modernizing your systems, your code base, your infrastructure, and everything. We discussed about some of the different ways you can approach modernization, the different challenges which are associated with it. And yeah, I hope from that webinar you got a good idea about what exactly the entire journey of modernization contains. So in this one, we're going to be talking about mixing the traditional architectural patterns in a more modern way. So to talk about this, today we have with us Abdel from Google. Abdel, would you like to give yourself a quick introduction?
Hi. Thank you for having me. Yeah, my name is Abdel. I'm a cloud developer advocate at Google. I'm based out of Stockholm, Sweden. I've been in the technology space for about 15 years and about 12 years at Google, and been working on things like cloud native and Kubernetes for the last 7 years almost. So yeah, I've seen my fair share of things.
Awesome. And I'm Sadan Kisti. I'm your host. I also work as a product executive at Devtron. And I'm also one of the organizers for the Cloud Native community chapters of the city of Nasik. So yeah, really excited to get on with this conversation with you today, Abdel. And as you mentioned, you've got 15 years of experience. So you've pretty much seen a lot of whatever tech has to offer us, both the good and the bad. So really excited to have this conversation with you today. For folks who might be new to our entire webinar series, we're hosting an entire series around modernization, different aspects of the modernization journey. So if you're interested in those, please do scan this QR code and stay up to date with our entire webinar series. So starting off with, why exactly do we need to have this conversation about modernizing system? Well, that's because a lot of technologies, a lot of industries, they evolve their technological stack at a really slow pace. So take banking, for example, or aerospace or healthcare. They are not industries which are tech dominant, not very tech savvy. So they just implement things that works for them. And so they may not necessarily need to keep constantly evolving their tech stack. There are a couple of more reasons for this as well. So a popular example is a lot of banks still are on COBOL, which is like a really, really old programming language. So Abdel, maybe you could walk us through some of the reasons why these different industries are so slow in evolving their tech stacks.
Sure. I mean, there are multiple reasons. I think that the first one, I'm always like, I get excited by new technology, but we have to always acknowledge the fact that um, there is this very basic principle that if it's not broken, don't fix it, right? Like a lot of times, stuff just work, and you don't necessarily have to like change it just because like um, any business typically have like a fairly limited amount of resources that they can use, both in terms of money and people. And sometimes you might have to do choices to make choices, and those choices could be you want to make your people focus on the thing that will make more sense to your business rather than refactoring whatever is already working, right? Now with that, obviously. That doesn't apply to all industries, and in a lot of industries, technology sometimes can hinder or be even like a factor that slows down how fast your business can move. The example you gave is pretty good, like banking. Like it started becoming super clear a few years ago, and it's even getting clearer as we're going. That there is a huge gap now between the old school banks and the new school banks, right? Just purely based on the customer experience, like how fast you can onboard the user, how fast you can create an account, how fast you can see transactions on your account happening, how reliable are these systems are. That creates a very clear like kind of distinguishing between the old school banks. I was reading a report recently about something like percent of Gen Zs, they prefer online banks rather than like, old school banks. Just because it's easier, you can open a bank account from your phone. You don't really need to go in person somewhere to like do that. Now, so that's just like one factor. Like a lot of people sometimes are reluctant to change just because they fear what change could mean. I mean, this is quite a normal human behavior that we don't know what change would mean for us, so we don't really want to do it. Other times, it sometimes means that like people, like businesses, just don't have the resources or they don't have the vision, and so depending on the, like as you said, like depending on this old school, I mean, businesses like. And another factor also that we also have to keep in mind is that sometimes it has to do with not necessarily risk, but the perception of risk, right? I mean, the very good example would be healthcare. Like in the healthcare sector, you are handling sensitive people and patient data. And you have to be super careful about what you're doing with this data, and you don't want the data to leak. And sometimes change could mean a risk of leaking the data, and therefore people don't want to run into that risk. I have friends who work in the healthcare industry, and you would be surprised how archaic and old school, like Windows 95, COBOL, and a lot of times these are actually systems that are completely disconnected. Like they're not even connected to the internet. Like a hospital IT system is typically not even on the internet because they want to minimize the risk as much as possible. So they don't want to connect that to the internet because that represents risk, right? So I think a combination of all these factors, like how risk aware or risk averse people are, how much resources they have, how much are they willing to like innovation, and also whether whatever they are using is already is broken or it's already working, are all kind of factors that could contribute somehow to like slowing technology adoption in general.
Love all of the points that you've mentioned, Abdel, like especially the point where people are really resilient to change. This is something which I noticed with myself. So for a little bit of context, I really love the self-hosting space. Like I've converted my laptop into my own NAS server and similar things. And with all these things, I just wonder like, why should I change what implementation I'm doing for having a backup server when this is absolutely working fine for me? So I have the similar take even with virtual machines versus serverless. Like I've got the virtual machine. Why should I switch over to serverless functions? So really love the points which you've mentioned here.
Yeah.
So before moving forward, let's discuss about what exactly are some of the technological paradigms. So one of the most popular technological paradigm, which I'm pretty sure that everyone knows about by this point, is a monolith and a microservice. So the short version of this is a monolith is basically when you couple every single component of your application into one single entity. And a microservice is simply when you break it down, you distribute you distribute the small components around a bigger network or around multiple computers. So those are two of the most popular technological paradigms. So this way we've got plenty of more paradigms, some which are related to the cloud native architecture. For example, we've got service meshes and other paradigms which are more over on the programming side. So Abdel, maybe you'd like to walk us through some of the most popular technological paradigms, whether they are used in a cloud native sense or whether if they existed before the era of cloud native.
Sure. I mean, like the two that you talked about, the monolith versus microservices, is your like traditional old school debates of how do you, like architect an application, right? Actually, what I'm noticing right now is that there is, I mean, it's quite interesting. It's like we're moving toward a situation or a world where these two things are kind of getting quite blurry in the sense that there is no more a clear separation or a clear way to distinguish monolith versus microservices. I can give another example, and we go back to this like monolith versus microservices. Like when cloud as a concept started, people used to use these like three terms like IaaS, PaaS, SaaS, like software as service, infrastructure as service, platform as service, to distinguish like clearly what is software, what is infrastructure, what is platform. Now that's getting very hard to to distinguish. Like, and there is even like new terms like function as a service, container as a service, database as a service, whatever, queue as a service. And the same thing is happening now for this like monolith versus microservices, because now you have the hexagonal architecture and you have your micro front ends, and which essentially micro front ends, for those who doesn't know, are a way for you to keep your application as a monolith in the backend, but break down the front end into multiple smaller front ends. So what this means effectively is that instead of having like a single web page that will render all the information, your web page is just composed of multiple smaller web pages that get rendered in parallel, and then they constitute the final web page. The most famous example is this Cloudflare has like a micro front end framework that you can use to do that. It has some advantages, obviously, and it has disadvantages. It depends, like, what are you trying to build, right? So anyway, so with this comment in mind, it's becoming very hard to kind of distinguish those. Even in the monolith microservices discussion, like sometimes if you're like talking to a really big organization, they might not have a single monolith. They might have multiple monoliths, or they might just not have, or they might have a single microservice that is shared across multiple parts of the organization. I mean, very famously, things like authentication, for example, is typically a service that everybody plugs into. Authorization is another example. Login and monitoring is a typical example. And this is assuming that your organization have centralized teams that can offer those like services in general, right? But like, if we want to really make the clear kind of distinguishing, monolith are the old school way of doing things, single binary. Releases happen every 3 months, every 6 months. You have to get all the company together to do a release, because you don't want to like, you want everybody with hands on deck to like make a single release. You don't release often. You build, and then you hope eventually your feature make it to the final production system. Microservices are the newer quotes unquote, because they didn't really grow up with cloud. I think that people were doing microservices even before. But yeah, it's like smaller components. Usually the way we describe microservices is that they are a single domain focused service. So a service that does a single thing, like a single task. Very easy to release, very easy to roll out, very easy to roll back. And these microservices sort of evolved and kind of thrived in the era of cloud and containers, because it kind of fits the container narrative, right? Container is a lightweight way of transporting or packaging applications. Microservices are by definition smaller packages of software, so they kind of work very well together. So that's kind of like, for me, the distinction, and we can talk about details if you want.
Absolutely. So love that you gave a really good, clear and concise overview of the entire microservices and monolith distinction. So what I would like to discuss with you about is some of the other paradigms which are evolving, which are emerging in the current day. So for example, there are a lot of different traditional paradigms, we can say, which are overtaken by AI. Folks want to integrate artificial intelligence, machine learning into basically everything today. So that's also one of the emerging paradigms which we can talk about. So what are your 2 cents on the whole emergence of AI and its integration into basically all the systems which have existed in the past?
Yeah, so it's quite interesting. Like, realistically, what I've been seeing so far, the utilization of AI so far, like the actual use cases I've seen are either, I mean, we can pretty much categorize them into 2 different categories, right? It's either you are using an AI as an assistant tool. So that's where things like Autopilot, Copilot, or Google Gemini or any code generation tool that you can think of comes into the picture. So it's essentially a little plugin built into your editor that can allow you to generate code, build code, look for documentation faster, do stuff like that. Maybe a smart IDE like Cursor, which was purpose built for this kind of things. That's one kind of utilization. or one use case. The second use case is integrating the AI into applications where the application is probably either doing something but doing it slow and not very well, or doesn't even have that feature, and the AI could allow that feature to be done in much faster, much better quality. The most common example here is doc summarization, right? So um, it used to be that in order to summarize a doc, you need to like split it down and maybe put it into some sort of like search database and search for keywords and build like a complex algorithm. LLMs are really good at doing that. So that's just very simple example. Or maybe still the use case is documentation, but or docs, but like not summarizing, highlighting important components or important parts of a doc. So you just upload a doc and then you say, give me the most important information, or extract some financial information, extract some, whatever, some numbers, whatever, stuff like that. That's also another kind of use case, right? Scraping web pages is another good example of how these LLMs can actually be used. I think we are still super early at the exploration phase. And just to plug this discussion back to this monolith versus microservices like paradigms as you talked about, I always consider an LLM as just another microservice, effectively. It's just a component that you just plug into your software and then call it with an API. It doesn't matter what that API is. It doesn't matter where that component sits. It could be like a cloud-hosted AI. It could be something that you run locally. It doesn't matter whether it runs on virtual machines, Kubernetes containers. It's just a component, just a microservice, right? So I think we're still very early at the exploration phase of what these things can do, right? Especially integrating them into applications. So we'll see. I'm actually super excited about how this will evolve over time.
Really love that answer, Abdel. And I really love how you basically called AI as another part of a microservice. And I'm pretty sure that that's pretty accurate because as far as I'm aware, most of the AI models so far, they just make an API call to the OpenAI servers. And from there, they put their custom model training. And that's how their local models are working, whatever integration it is with their software.
Exactly.
So my next point of conversation is going to be a little interesting because I personally don't think there's any straightforward answer to this. What exactly would we consider as a modern paradigm? And on the other hand, what would you consider as a legacy paradigm? Now, I think depending on who you are, this answer is really going to differ for you. Because if you're, let's say, for example, one of the most leading tech player in the world, you're innovating on technology, then you might even consider containers as a legacy paradigm. On the other hand, if you're in one of the slower evolving sectors, for example, banking, maybe you're still considering as self-hosting your own infrastructure as the peak of modernization, right? So really curious to hear your thoughts, Abdel, on how exactly would you go about categorizing what would be a modern paradigm and what would be a legacy paradigm.
Yeah. So I think, as you said, like modern or legacy is depends on the point of view of the person asking or answering the question, right? Uh, um, and as I mentioned earlier, because we're getting to this space where things are getting slightly blurry, we don't really know where do we even draw the line between microservices and monoliths or between any of these architecture patterns, right, anymore. Distinguishing modern versus legacy. I just remember like a few years ago, I was in a customer meeting somewhere, and I showed how you can create a virtual machine in the cloud in like 30 seconds. And the people like I blew the mind of some people because a lot of people were saying, "Oh yeah, it took us like 6 weeks to get like a virtual machine created in my company," right? So for them, obviously, whatever I was showing them was very modern. To me, that's like the base, right? That's the basics of how cloud works today, right? So also the other thing is that it's very important to not fall into the trap, and this is just personal opinion, not fall into the trap of clearly labeling certain technologies or a specific technology as either modern or legacy, because technology and how do you use it are two separate things. And let me explain what I mean. Like, you might have an internal cloud platform. Like, like the example is, let's say that you do everything on-prem, but you are using Kubernetes, you are doing platform engineering, you are building stuff with Argo CD, Backstage, all that stuff, but you're doing on-prem, right? Like everything is on-prem. Like, do you consider that legacy? Do you consider that modern? It's debatable, right? I think that like modern versus legacy probably has to do more with the approach rather than the technology you use, right? In my opinion, or at least the approach is the first criteria, and then the technology is the second criteria. Another example would be, I don't know if this is something that people are doing. If you are able to like containerize a COBOL application, would that be considered modern or legacy, right? Or containerized a Java 8 application. Java 8 is like an old version of Java, right? Would that be considered like modern or legacy? I think it has to do initially with like the how, like how do you approach technology, uses, choices, whatever, and then the followed by the which. So which technology do you actually use is like kind of the second step in that discussion. So, and I've seen my fair share of like people doing all sorts of stupid things on the internet, on the cloud, and then or people doing all sorts of like modern things, but doing them on-prem. So obviously, if we want to like kind of give a high-level guidance to kind of wrap your head around it, I would say if it's microservices, if it's using like recent frameworks, kind of modern programming languages, and even modern programming languages is quite a loaded term because Java 23 is by definition a modern programming language, right? If you are doing things in cloud, if you are doing things, or at least doing it the cloud way, which is, even if it's an internal cloud, that's probably could be considered modern. If you are COBOL, on-prem, Windows XP, that's probably legacy. Another also thing that is quite interesting is to keep in mind is like the term legacy sometimes mean different things to different people. So if you ask a developer what do you consider as legacy code, they would probably always answer you legacy code is code that was written by somebody else who left the company. Like it's code that I didn't write and I don't know how it works, right? Like it's probably just code that I inherited and I have to like maintain. And sometimes the follow-up or the longer answer is code that probably doesn't have documentation. That we don't really know how it works. We just know that it's code that is like running somewhere. So that's how I would distinguish it. I don't know, what do you think? Like, I don't know if you have any follow-up questions on this.
Yeah, I actually really love the point that you mentioned about legacy could even be like somebody who has written the code and left the company. I was watching a podcast recently in which they mentioned a lot of these systems, like the banking, the government systems, they still run on COBOL because the people who wrote them are literally in the grave. Like these systems are so old that the original creators, uh, they're no longer with us. So yeah, that's also legacy in a way. And yeah, migrating those systems to modern technologies, modern programming languages, it's just really, really unlikely because they're holding so much critical data, like entire government infrastructures, entire military infrastructures. There's no way anybody's taking a risk to try and modernize that just to be up to date with the latest and greatest, right? And another point which I want to mention within this is about evergreen technologies. So one point you mentioned is categorizing modern versus legacy technologies based on how they are used. So from that aspect, we could categorize Linux into a modern technology. Although when was Linux created? Somewhere in the 90s, right? But we're
Yeah.
still using it very, very heavily. Same thing with eBPF. Like even I don't know when exactly was eBPF created, but today it's used in some of the most modern, some of the most cutting edge technologies like Cilium, for example. So yeah, this is stuff which I would like to categorize in the evergreen category, which would be Linux, eBPFs, even the concept of platform engineering. If I'm not wrong, then platform engineering has existed for like a couple of decades, for like at least 20 to 30 years, but it's still used and we're still actively innovating on that. So there's no way that just because it's old, we can categorize it as legacy, right?
Yeah. I mean, there is a lot of another good example that I've seen recently is WebAssembly, right? Like WebAssembly have existed in the browser for a very long time, and now it's kind of making a comeback with it being a backend technology. Go recently, the programming language Go recently launched Go by 1.25, full support for WebAssembly, so you can actually write code in Go and just compile it into WebAssembly. So it is also like maybe to some people it's old technology, but it is something that is like heavily being used these days because it solves a very particular problem. So
Awesome, love that. And I love that we were on this conversational thread because the next slide directly ties into it. So if folks in the audience are aware, about 1 to 2 years ago, AWS announced that they were moving from a microservice architecture to monoliths. Why? Because microservice was actually getting too expensive for them, not just in terms of cost, but also in terms of performance. So, Abdel, maybe you'd like to go ahead and brief us about this entire story.
yeah, so this was an article that was published by some people working on in Amazon, right? And so they they are working on this thing called Amazon Prime Video, and they build it like a quality service, and the quality service analyzes the quality of videos. So it takes videos and break them down into individual frames. So let's say, for example, a movie which is 4K, 30 frames per second. That's essentially 30 individual pictures or 30 individual picture for every second of the video, and then analyzing every single frame to look for quality issues, right? And so it was not very clear in the article if they are sampling, if you just like take samples or they're like analyzing every frame, but like it doesn't matter. And so initially they designed it in a microservices way using, I remember it was Lambda, Amazon Lambda, or AWS Lambda. And so they did that, and they had like multiple microservices. I think they had one microservice that breaks down the video into individual frames or into individual pictures, and then they had another microservice which analyzes those pictures. So both of them runs on Lambda, which means that every time you are breaking down those videos into individual pictures and making a call to analyze a picture, you are doing a Lambda invocation, right? And so their price, like their cost, kind of over rocketed over time, and so they just moved that all from a microservice based architecture running on Lambda into a monolith application running on ECS or EC2, I don't remember, ECS I think. So basically containers, and they realized something like 90% cost cutting or cost optimization, and they wrote this article which kind of like created a lot of debate on the internet, partially because it was missing a lot of details, partially also because, to me at least personally, when I saw it, I was like, but to me it sounded like something that could have been or should have been avoided from the beginning, because like it shouldn't take that much brain power to think that making a single call for every second of a video 30 times per second would not be cheap, right? And I'm not very familiar with how AWS pricing model works, but like this is something that should have been questioned in a way. Like somebody should have raised that as like a potential problem, right? So to me, it sounded like something that was obvious, but it might not have been obvious for a lot of people. So there was like a lot of debate, and there was a lot of people talking about it. So that's essentially the TLDR, right? So that's how this kind of use case works.
Hearing about the fact that AWS was sampling literally every single frame, my mind was just boggled. Like one frame alone is like huge amounts in bandwidth. How are you like streaming to your customer at the same time reverse streaming the whole thing just to improve the streaming quality? Like that is actually a technological feat and also quite mind-boggling.
Yeah,
Another
and
example,
that,
yeah,
yeah,
good.
and that's something that I think was quite. I think if I remember correctly, it was not really clear in the article whether they are doing that or whether they're sampling. So not analyzing every single frame, but analyzing every other frame or every 3 frames or something like that. But like, yeah, it doesn't matter. Like it was. I think that the combination of not enough details and the fact that they wrote this like super catchy title of like saving 90% cost by moving from microservices to monoliths, made it such a way that it was a debatable use case, I would say.
True. Like leave in gaps so that your reader is going to try to fill in the gaps on their own. Just like classic storytelling. So there's one other story which I really like around the whole thing about using older technologies. So Discord, a really popular chatting platform similar to Slack, they published an article back in 2018, I believe, that they were using WebRTC for handling millions of voice calls. Now, if you're familiar with WebRTC, it's not that great in terms of scaling. Like maybe you can handle 10 concurrent voice calls, but if you try to go over that limit, it's literally going to break and you're going to have drops in communication and stuff. So what Discord basically did is they modified the entire core of the WebRTC framework, and that modification actually allowed them to handle millions of concurrent voice calls. So that's also one really amazing story which I like. Like you're using this older technology, refining it, changing it up so that it can handle these modern levels of scale.
Yeah, and I mean, I would not consider WebRTC as an old technology. WebRTC is quite, I mean, not quite modern, but it didn't exist for a very long time. It actually was initiated at Google, by the way. WebRTC is something that Google open sourced. And it's just a set of libraries in the browser that allows you to do audio and video communication without needing to install extra plugins. That's the whole idea of web real-time communication. But yes, I agree. Like it's one of these things where sometimes relying. I mean, the same. Just another example that quickly jumped into mind is when Google introduced this thing called Quick. So Quick is a Quick without K. And it was the protocol that gave the evolution to HTTP 2, because HTTP 1.1 was not really good at streaming. So there was some limitation in HTTP 1.1 that made YouTube actually pretty slow for a lot of people. And your video would like hang sometimes or drop out or it would buffer and stuff like that. And Google had to like find a solution, so they couldn't actually wait for the standard to evolve. And so instead of waiting for the standard itself to evolve, they just introduced their own thing, which then eventually became HTTP 2, or at least part of it became HTTP 2. And this is the example of like big companies that have that possibility or that power to push the boundaries of what's possible with technology. I don't think that that's something that everybody can do, right? Unfortunately. So, but I think I like the approach that, like, you should question the status quo. You shouldn't just accept that things are what they are just because you cannot change them. And you should probably look beyond the technology that you're using. Maybe there is something more interesting that you could like use, right?
True, really love that point. And yeah, it's like questioning every single thing about what technology you're using. I think like that's the pillar about innovation. Like you can't have innovation if you don't ask that fundamental question. So the entire reason like we've got all these programming languages is you can literally read the source code. If you're using a library, you can read the source code of the library, see what all functions it's invoking, how is it working, and then try to reverse engineer it, break it down, and potentially find that one flaw which you can improve. And yeah, that's the entire key to innovation.
Exactly.
So yeah, I'd like to talk with you about how an organization can go ahead constantly evolving their tech stack. So we've discussed how folks are still using legacy paradigms, how they are going to be integrated with modern systems. Even saw two really good examples with Amazon, with Discord, how they are approaching it. So yeah, according to me, like evolving or moving to a modern architecture is just all about abstraction these days. The main architectural changes was monoliths to microservices. You've done that. Now the next steps are mostly just about abstractions. You introduce a platform on top to abstract out your microservices, for example, like share access of them, like get visibility into who's responsible for which services. And there are other levels of abstraction as well. a service mesh, for example, that's also abstracting a lot of the networking complexities. So, Abdel, according to you, how can an organization constantly keep improving their tech stack to stay on top of things?
Yeah, I mean, there are kind of a couple of ways you could approach this, right? Like, one of them is, I mean, it depends. I think it depends in which kind of phase you are in your journey, right? Like, if you are the kind of organization that is in the middle of like a massive migration, and migration doesn't necessarily always means moving from on-prem to cloud. Migration could be moving from somewhere to somewhere, right? Like, it doesn't really matter. It could be evolution. Could be sometimes like something like looking at what you have and deciding whether do you still actually need it or not. Like, do you still need this piece of technology? Can you replace it with something else? Can you buy some off-the-shelf software? Should you actually be developing everything in-house? Stuff like that. Like, these are the kind of questions you should be asking, right, yourself. Outsourcing, moving everything to somebody else so you can focus on your core business. This is like, you just look at what you have and ask the question, do I still need this? If you don't need it, it's probably time to like retire it or just not use it anymore, right? The other approach, I mean, this is not technically an approach, or not even, this is, in my opinion, something that everybody should be doing. Is you should always be investing in people. As in, people need to upskill and they need training, and you should be investing in making sure that these people are upskilling and training and learning new things, right? You cannot just rely on people in technology to come up with innovative solutions without giving them the time to go invest in themselves and learn new things. This can be implemented in many ways. It could be as simple as dedicating training budgets, or sometimes giving them the opportunity to go to technology conferences so they can kind of like experience it and see what other people are doing, and listen and hear what other people are doing. This also could be a good way of approaching that. The third thing is, I would say that there is this like effect in the industry, which is people get overwhelmed when they see big tech companies launching and talking about new stuff. You don't necessarily have to follow all the new trends. You should just look at the stuff that makes sense to your business. Like what Google and Amazon and Discord are doing doesn't necessarily apply to everyone, because these companies operate at a scale that not everybody has, and the kind of problems they have to solve are problems that not everybody have, and you probably will never have unless you get to the scale of the size of these companies, right? The other thing that I would say probably that is kind of becoming very crucial for me personally is invest in open source. Open source is going through like a massive seismic change. A lot of fundamentals of how open source work are being questioned and being challenged. Companies are just changing licenses left and right. People are, taking software from open source to closed source, or any form of this, and being able to question, being able to, like, as a company, instead of just being a consumer of open source, also being a contributor, means you are able to probably sit at that table and dictate or tell or make sure that people understand your side of the story and understand why certain decisions cannot be taken without you, right? And that sadly is not always possible for all companies, because it depends on the size. But at least having that sort of visibility into the space could be good. Because, like, the reality is, what could happen is, if you're relying on a piece of technology and then suddenly tomorrow the company behind the technology decide to switch the licenses from open source to closed source, if you have enough exposure and experience, you could just like decide to fork it and just maintain it yourself, right? Like, this is something that have happened many times before. So this could be a very good approach. And, generally speaking, just like like the tech industry is very cyclical. There is like a lot of cycles, and we just keep going back to the same thing after a certain amount of time. WebAssembly is a very good example. So I think I predict that in 10 years, Kubernetes will be cool again. containers will be cool again, and we will not be talking about LLMs. So a lot of times people feel overwhelmed with what's going on, but I think that if you are patient and kind of you take your time to like soak it in and understand what's going on, you will feel that things just keep coming back essentially.
Love those points that you mentioned. And like at the end of the day, everything's going to cycle back and it's going to be like a full circle. So Kubernetes recently had its Linux movement, and Linux itself isn't really dead. Kubernetes
Exactly,
runs on top of Linux at the end, right?
exactly.
So yeah. So everyone, thank you so much for attending. Abdul, thank you so much for coming. Like there are a lot of new things which I personally learned, and I'm sure our audience learned about it as well. And yeah, folks, if you want to stay up to date with our entire webinar series, please do scan this QR code so you can stay up to date. We've got really exciting sessions lined up, and I personally am really excited to have those conversations with more amazing folks like Abdul. And yeah, Abdel, once more, thank you so much for coming on and having this conversation. And I really had a fun time having this conversation. And hopefully, we can have you back on later for a future webinar.
Thank you very much. I'll be looking forward to. Thank you.